In this video, we're going to look at the time value of money. Money has a time value. $100 today is worth more than $100 a year from now because $100 can be invested and you'll have more than $100 a year from now. So let me show you how this works. If I invest $100 today at 10% interest for 1 year, I will get back my $100 plus I'll get the 10% interest. And so what I end up with is 100 times 1, that's 100, plus 100 times 0.10, which is 10. So I get my principal back. I get 10% interest of the 100, and I end up with $110. If you understand that, as simple as that is, you understand the time value of money. You understand the formulas that we're going to be using. It really is this simple. Now we'll play around with this. We'll expand this a little bit, and it will sometimes be disguised as being more complicated, but it's not. This is it. Okay, well, let's take that 110 and invest it for a year at 10% interest. So we'll take our 110, we'll get our 110 back, plus we're going to get 10% of our 110. And we'll end up with $121. Okay, now take a look at this. Notice we have 110 here, and we have 110 here. And 110 is equal to this right here. So what we can do is we can take all this and substitute it for this, right? Because this is equal to this. So let's do that. Okay, I'm going to erase this. And I'm going to write this here. Okay. So now what do we have? We have $100 plus 1 plus I times 1 plus 0.10 plus 1 plus 0.10 equals 121. Notice we've got two of these here. Well, we can clean that up a little bit, write that a little better by using an exponent. We don't have to write that twice. We just put in there. That's two of them. So let's get rid of this one. And, well, let me move this 100 over a little closer. There we go. Okay. So if we're going to invest $100 for 2 years, which is what we did, we invested it the first year and ended up with 110. Then we invested that 110 another year, ended up with 121. Well, rather than go through that twice, we can just say 100 times 1 plus 0.10 squared gives us 121. Well, let's do that again. Let's take our 121 and let's invest that for a year at 10%. And we will get roughly 133. I'm again rounding a little bit. Well, we're going to do the same thing we did before. We have 121 here, and we have 121 here, and 121 is equal to all this here. So we can take this and substitute it for this, right? Because they're equal. So let's do that. All right. Well, we have two of these right here, right? We have one of them here. And we usually don't write exponents when it's 1, but, you know, we can put the 1 there. So what do we do here? We have the same thing there. We just add the exponents together. So what we have are 3 of these. So let's erase that. And whoops. Put an exponent of 3 there. And we'll get rid of that. And let's move the 100 over a little bit. Okay, there we go. Okay, so if we want to invest $100 for 3 years, it's 100 times 1 plus 0.10 to the third equals 133. All right, now if we were going to invest $100 for 4 years and you had to make a wild bet, just a crazy speculation, what would you speculate that exponent's going to be? Yes, a 4. If you invest it for 25 years, see, now the exponent's getting really handy. That's going to be a 25. And you don't want to go through this 1 year at a time 25 times. So the exponent becomes a 25. So this is our time value of money or compound interest formula. So this here is called present value. That's the cash flow that takes place today. Okay? This here represents the return of our present value or principal. Okay? That 1, we're getting it back. This here is the rate of change. Rate of change. Greek letter delta, we use this, change. Rate of change. It could be an interest rate. It could be an inflation rate if we're trying to determine what inflation is doing to our purchasing power. It can be dividends, stock, capital gains rate. It's just a rate of change, whether it's interest or capital gains or dividends or whatever it is. It's what we're getting back. It's the rate of how much things are increasing, hopefully increasing. And this is the number of periods. That's the number of periods we're investing for. Okay? Now, the periods could be years, the periods could be quarters, the periods could be months or days. So we have to pay close attention to what the periods are. And this here is our future value. That's what we're getting back in the future. So present value and future value, those are pretty intuitive. And the return to the present value or principal, our rate of change, the number of periods, and there we have it. So this formula. Write a little prettier here. Present value times 1 plus, I'm going to put I, so that it was commonly used, interest rate, but it could be, dividends or capital gains or inflation or whatever. It's just the rate of change equals future value. Let's not forget the N. We often use N there. So present value times 1 plus I to the nth power equals our future value, and that is where our time value of money or compound interest formula comes from. And we'll be seeing that in action in the next video.